Hello everyone, I'm Akshat Sangomla. I work as a reporter at Down to Earth. I cover science and technology and with a specific focus on natural disasters, climate change and meteorology for Down to Earth. I'm going to speak to you about the India Meteorological Department and how the data from the IMD can be used uh, for analyzing, for understanding the Indian weather and in the long term, the Indian climate. So I'll basically navigate through the IMD website and I'll show you where you can find the data and how you can read it and how you can understand it. So this is the website of the Indian Meteorological Department, and here in the center of your screen, you can see that the current weather conditions in New Delhi are 17 degrees Celsius. Uh, like the temperature is 17 degrees Celsius, the humidity is 100% relative humidity, and there's no wind. And this was basically the observation was made at 2:30 a.m. on 26th February. And on your left of screen, you can see an India map which shows current weather throughout the country. And you can see that many of the states in Northwest, West, Central, and Deccan, and some of the eastern states have cloudy weather. So if we can go closer into Rajasthan, we can see that many of the major cities have a cloudy weather. If we go to Bikaner, so Bikaner, currently the temperature is 20.6 degrees Celsius and the relative humidity is 44 degrees Celsius. There's no wind in the city. Similarly, you can go to other states and check what is happening there. So this all is current weather, what is happening right at this point of time. And so on the right hand side of your screen you can see satellite imagery of the weather conditions over India. You can see that not a lot of cloud cover at present, extensive cloud cover at present, but there's cloud cover over Pakistan, Afghanistan, Iran, and also over Tibet and China. And both these places influence India's weather. Whatever is happening here also influences what is happening in the country. Now, what I'll do is, so the main main web page of the IMD is divided into four different sections. The first is warnings, the second is nowcast, weather realized, and specialized forecasts. Warnings have are categorized either subdivision wise or district wise, and if we go to district wise warning, giving out warnings and alerts is one of the major mandates of the IMD, and so they categorize their warnings by four different types. The first is no warning, and that is that you don't have to worry about any disaster or any heavy rainfall or anything else. The second one is watch, wherein you have to be a little careful. And then there is alert, the orange, and then there is the warning, where the authorities have to take action now. And so you can see that for the 26th of February, not a lot of warnings or alerts are there, but there are a few areas in the north, in the northeast, and in the south where there is a watch. And for example, Chamoli, where the district where the flash flood disaster happened recently, there is a thunderstorm and lightning watch. Similarly, in Lohit, which is a district in Assam, there is also a thunderstorm and lightning warning. Similarly, IMD also forecasts the weather conditions for the next few days. So similarly, you can see the warnings for say 27th of February, then 28th of February, and so on. Nowcast is a bit different from warnings, as in it is what is going to happen in the next few hours or an hour. So this is what the condition is going to be in an hour or so. And say, for example, Karbi Anglong, which is a district in Assam, these are the conditions that are going to be prevailing. So light rain, there's light thunderstorms, maximum wind speed of around 40 kilometers per hour. Now, if we go to weather realized, so in this, the two important things that you should keep in mind are the actual rainfall and actual temperature. So these are the actual rainfall maps, and so this central map gives you the average rainfall of of the country. Like this is the rainfall that should happen at this point of time in the year, in this season. And this is the actual rainfall, that has actually happened, and this is the anomaly, that is how much less rainfall has happened. So you can clearly see from the index here that most of the country is deficient, has deficient rainfall between -5 and -10%. This index shows you the absolute rainfall for the first two maps. Anything light blue or sky blue or dark blue will show you excess of rainfall, and the greens show you some amount of rainfall basically. And if there is no color, that means that there has been no rainfall. Now we'll go to actual temperature. So here, this is the map for 24th of February. The minimum temperature map is for 25th of February, and the mean temperature map is again for 24th of February. So the first three maps are absolute temperatures, the temperatures that were measured, and the bottom three maps are anomalies. That is how much deviation there was from the normal temperature that should be there for this time of the year. So maximum temperature, you can see that already we have crossed into many parts of central India, West India, and eastern India have crossed into 36 and 38 degrees Celsius of maximum temperature. And you can clearly see from the maximum temperature anomaly that these temperatures, especially in the northwest, and some parts of central India, very few parts of central India, are have a high deviation from the normal, which is as much as more than basically 5 to 8 or even 9 degrees Celsius above the normal. And many of the southern states have much cooler conditions, basically up to 4 degrees Celsius below the normal. This is mainly because of the rainfall, which we'll see later. That rainfall has been happening for quite a while in the southern part of the country, and this has caused the temperatures to go down. You can also look at the fourth section, which is specialized forecast for different kinds of departments, for different kinds of activities like tourism. There is a thunderstorm prediction, there's a health meteorological bulletin, there's air quality index, which is important for cities like Delhi, which are highly polluted, or Lucknow, Kanpur in UP, which are also highly polluted. There's also a pilgrimage forecast. There's a forecast for the power sector because they require it for load shedding and other distribution and generation related activities that they undertake. So now, now we'll get into the data. We'll go back to the home page, and we'll go to rainfall information. So rainfall information can be viewed in two ways. The first is the map format, which you can see on your screen right now. So this is the daily map. So this is the map for 25th of February. So there's not been a lot of rainfall at all. So no data. So it's either no rainfall, no data, or large deficient. That is, there has been some rainfall, but that is very, very less. So these indices are very important to read rainfall data. Large deficient is basically 60 to 99% less than normal. Deficient is 20 to 59% less than normal. Normal is between -19% 19% deficient and 19% excess, and excess is between 20% to 59%. Large excess is 60% or more. So you can clearly see that there's not been a lot of rainfall on 25th of February. But if we look at weekly, that would be from 18th of February to 24th of February, there has been some rainfall in the week. And in fact, there has been excess and large excess rainfalls in a lot of the districts of Odisha and some districts of even uh, even Andhra Pradesh, like Vizianagaram. And there has been, so other places there has been rainfall, either normal or large deficient. That is, rainfall has been recorded, but it's very less. Now, if we go down south, there are a few districts in Kerala and Tamil Nadu where there has been excess rainfall. Uh, Now you can view this in different. So you can also see the monthly map where you can see. So this is from 1st of February to 25th of February, and you can also see the cumulative, which is from the 1st of January to the 25th of February. So similarly, data will be available that how much rainfall has happened and how much is it excess or is it large deficient or deficient or normal. So you can also view this as state-wise districts. If you go to say Uttar Pradesh, you can see that a lot of the districts have no rainfall, right? Then if you want to go down south, say Kerala, yeah. So Kerala, two of the districts have had rainfall, and one is Wayanad, which is like not much deficient rainfall, and Pathanamthitta has had excess rainfall of 489%, which means almost five times the normal. So now this is the same thing, meteorological subdivisions according to the meteorological subdivisions that the IMD divides the country into. You can also go by states. So all these are different divisions, and you can go by weekly, monthly, cumulative, whatever is required, even by river basins. It can be viewed. So even by river basins, you can view the data. So we'll get into rainfall statistics, which can be viewed as a table. So this basically shows it lists all the states and union territories of India, and it tells you whether how many districts have had a large excess rainfall, normal rainfall, uh, from 1st of January to 25th of February. And you can clearly see that the South Indian states have a lot of large excess districts, and the North Indian states and Central Indian states and Northwestern states have a lot of large deficient districts, which clearly shows that where the rainfall distribution has been. Now, if we go into state-wise rainfall distribution, which is, yeah, so these are again a list of states divided region-wise, and here also, so here you get absolute rainfall. So this is this column. The first column shows you what amount of actual rainfall has happened. The second column shows you what amount of so what should the rainfall have been for this time of the year at in these states, and what is the percentage departure? What is the deviation from the norm? And similarly, this is for 25th of February, and this is for the entire period. Same actual, normal, and percentage departure. You can clearly see the northeastern states have had almost no rainfall, and the South Indian states have had a lot of rainfall. Uh, Now, if we go, so you can also view this data district wise, and you can download it and analyze it and view it. And so if you say for Arunachal Pradesh, you can clearly see that a lot of the districts have had no rainfall between 1st of January and 25th of February, which means that a lot of the farmers would be having issues if they are going to sow the crop, or if they have already sown the crop and they need water for certain agricultural activities, because Arunachal Pradesh and in fact the entire northeast is heavily dependent upon rainfall, as there are no other natural sources of water for them. Even the mountain springs are fed exclusively by the snowfall that happens, and not by the glaciers. There are not a lot of glaciers in that part of the Himalayas. So Assam also shows mostly no rainfall except for one district, which is Barpeta, which has large excess rainfall, and Buxa, which has normal rainfall, which is highly unusual that a large state like Assam, would have only a few districts where there would be some amount of rainfall and a large amount of rainfall, and the other districts would have absolutely no rainfall. So you can also view data by weeks. There you can get the trend as to in which weeks there has been more rainfall and in which weeks there has been less rainfall. For example, by weekend of the 13th of January, you can see that West Siam district in Arunachal Pradesh has 233% excess rainfall, and it steadily decreases. It becomes large deficient, minus 74 in the week of 3rd February, and then it picks up a bit by the weekend of 17th February. So this is week by week departures. You can also see week by week cumulative, which is a bit different. So West Siang, you can see that it's steadily decreasing. It was a large excess, then it became normal, and then it has gone into deficient. So I'll end my presentation here, and you can always go through the website and check for other kinds of data. There's a lot more data in it that will depend upon your requirement of analysis and what you want the data to tell you, basically. Thank you very much.